Let f be a one-to-one or injective, positive valued function defined on R. Assume that f is differentiable at x equals 1, and that in the xy plane, the line y minus 4 equals 3 x minus 1 is tangent to the graph of f at x equals 1. Let g be the function defined by g of x is equal to root x for x greater than or equal to 0. Which of the following is false? Oh my. Okay, so a couple things we're given here are we have all right, so maybe we should just work through these one at a time. Okay. First, with the information that we're given, we can evaluate what the derivative of f is at x equals 1 because we have this tangent line. We should also be able to work out the value of the function there because we have a tangent line, meaning we have an intersection point. Okay, so in fact, I can write, if I take y minus 4 is equal to 3 x minus 1, and we know that this is tangent to f at x equals 1. So this says that if I substitute x equals 1 in this says that y is equal to 4, which means f of 1 is equal to 4, and f prime of 1 is going to be equal to 3 because the derivative of f at 1 is going to be equal to the slope of this line, which is clearly 3. So that rules out option A right here. That rules out option A. So option B, if I look at option B, says that f inverse prime at 4 is equal to 1 over 3. So because f of 1 is equal to 4, we know that f inverse of 4 is equal to 1. And the, if f prime of 1 is equal to 3, then by taking f inverse, maybe I should draw a very quick sketch of what this function might look like. So here's x equal 1, that's y is equal to 4. So we know that the function has a slope of 3 here. Okay, so the slope of that line is 3. That's what the derivative of the function at this point is going to be. And so the slope of this line, if you think about the slope in the opposite direction, so rather than rise over run, it'll be run over rise. If we flip this graph along the y equal x line, then we can get kind of like the inverse functional relationship of this line, and that will have a slope of 1 over 3. So f inverse prime of 4, it is in fact equal to 1 over 3. It'll be the reciprocal of this. And so option B is not the correct answer. That is a correct statement. Okay, let's look at C. In fact, what we can do is we can just assume, because of the way all these statements are given, the only thing that really matters is the value of f at x equals 1 and the derivative of f at x equals 1. So let's just assume that f is given by 3x minus 1 plus 4. We're just going to assume this, and we'll get correct statements for everything. So let's look at option C. We have g of x is equal to root x. Okay, so then f of g, this is equal to 3 root x minus 1 plus 4. So fg prime, let's call this h. I guess this is h of x. So then h prime of x is equal to 3 over 2x to the negative 1 over 2. So h prime of 1 is equal to 3 over 2. Okay, so I see that this is not what's given. The thing that was given was fg prime of 1 is equal to 5. Okay, but let's go through options D and E and also confirm that the statements are correct. So option D, g of f prime at 1. Okay, so I need to compute g of f of x. Well, f of x is 3x minus 1 plus 4. And then I take a square root of this whole thing. I'll just raise to the power of a half. Okay, so g of f prime of x is equal to 1 over 2 times this, the power of negative 1 over 2, and then I multiply by the derivative of the inside, which is 3. Okay, and if I evaluate this at 1, g of f prime at 1, so this becomes 3 over 2 times 4 to the negative 1 over 2, which is 3 over 4, but that's also not what we're given. Oh, I made a mistake in part C. It's not f composed with g, it's f times g. So let's redo part C. So h of x is f of x, g of x. So I have 3x minus 1 plus 4 times the square root of x. Let's just compute the derivative directly here. So I have 3 root x plus 3x minus 1 plus 4 times 1 over 2 x to the negative 1 over 2. So h prime of 1, 3 plus 4 over 2 times 1, and that is in fact equal to 5. Okay, so option B is not the right answer because that statement is correct. Okay, yeah, I should have. Why did I think this was functional composition? I don't know. Okay, so it looks like D is the correct answer because this is not equal to what's given of 1 over 2. But again, I'll also verify option E. So now we have g of f at 1. Okay, I already computed g of f. G of fx is equal to 3x minus 1 plus 4 to the power of a half. And so g of f at 1 is 4 to the power of a half, which is 2. Okay, yeah. So the correct answer here is D, because that's the, I mean, just by computing these things by hand, we see that that's the only one that doesn't come out to the correct answer. Or, yeah, that's the only one that does not come out as what's given. There might be an easier way of working through these rather than computing them all by hand. Maybe there's like a quick way of seeing with the information given which of these options can't be correct. But I think by essentially just assuming that f of x is given by this function, this straight line, it's pretty straightforward to do all the computations. So I don't really see anything wrong with that. But yeah, maybe there's a quicker way. someone wants to give me a different approach to do this faster, you can leave it down in the comments. Thanks for watching.